This is January 2016, paper 1. This is question number 6. So here we're looking for which diagram shows the reflection of a ray of light at a plane mirror. So what we know about reflection is that the angle of incidence equals the angle of reflection. So if we draw our normal line here, and here, and here, then this angle should be the same as this angle. So in this one, it's definitely not. This one, definitely not. This one is doing something really weird. So the only one it could possibly be is that one. The diagram, on the diagram, draw the normal for this refraction. So I'm going to try and draw this, but I've got a terrible pen. So there is my normal line, and it should be at 90 degrees to the surface. And they'll judge that by eye, but it should be 90 degrees where it hits. That's what everybody forgets. It's where the ray hits the surface. On the diagram, mark the angle of refraction. This is the angle of refraction. That's why the normal line is there, in order to measure these angles. So we put the normal line in because it's all the angle of incidence is between the incident ray and the normal. Angle of refraction, refracted ray, and the normal. Okay, I can't help you with this one. You're just going to have to measure it. So what you would do is you put the protractor on. I'm going to draw it on. I put the protractor on like this, where this is going to be 90 degrees. So put your normal line along the 90 degrees and then count across. What people mistake with this one, when you do this, and this is our 90 degrees, they count to here and they say stuff like, oh, I measured to 67. So that means, oh, this is an angle of 67. They forget that what they're actually doing is measuring between here and there. So you want to do 90 minus 67. So in this case, this angle of refraction, they wanted 27 degrees. And they would give you within 3 either way of that. State the relationship between refractive index, angle of incidence, and angle of refraction. Well, n equals sine I over sine r. 1 mark, just stating it, and we're going to calculate the angle of the refractive index. So let's have a look back. It tells us that the angle of incidence is 43. So for this equation, I can just put sine of 43 divided by, I worked it out before, sine of 27. They will give you error carry forward. So even if you can't measure the angle of refraction, don't know how to do it, take a guess. If you said 30 here, you wouldn't, oh, you would get the mark actually, because that's plus or minus 3. If you said 31, okay, you're not going to get the mark, but if you put 31 in here, you could get this mark. So you should find refractive index is 1.5. Then they go on to here. What is the name given to this effect? Well, it's total internal reflection. Total internal reflection. And you can see that because none of the light is getting out. It's not refracting out of the glass fiber. It's all reflecting in with the glass fiber. So for 3 marks, explain. So you should use the word because. So light reflects inside the fiber. Terrible handwriting. Inside the fiber. What do we know about total internal reflection? Well, the angle of incidence, terrible, is greater than the critical angle. So it bounces around. So light reflects to the inside of the fiber because, we can even put that word, because the angle of incidence is greater than the angle, greater than the critical angle. So it starts bouncing around in there. The third mark point in here is they say because light travels slower, in glass. Now I'm not quite sure what effect that would have on your explanation. Explain what's happening to the light in the fiber. Oh, okay. So they just want to know light is reflecting because it's at the critical angle. What else is happening? It's traveling slower. Light's traveling slower in the glass. Okay, that's not too bad. Okay, that is question number 6.